graphing relationships. Our objective is to match simple graphs with situations, as well as graph a relationship. Who uses this? Cardiologists can use graphs to analyze their patients' heartbeats. Let's look at relating graphs to situations. The air temperature was consistent for several hours at the beginning of the day, then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Choose the graph that best represents this situation. So let's look at what we've got so far. Our first piece here, the air temperature was consistent for several hours at the beginning of the day. Then it rose steadily. It stayed the same temperature for most of the day. So then it stayed the same temp for most of the day before dropping sharply at sundown. So we need to find a graph that starts out consistent. So we're looking at, all right, starts off consistent. We know that it cannot be graph C. All right, now we need, then rose steadily for several hours. So rose steadily for several hours. Both of them fit. All right, so now let's look at same temperature for most of the day. So the only one that stayed the same for most of the day would have been B, because A comes up and then drops sharply down and then stays the same. So we're looking at B. All right, let's look at a couple vocabulary words before we continue. A continuous graph is a graph you can draw without picking your pen off of the paper. So it's continuous. It doesn't stop. A discrete graph is only distinct points. The values between are not included since they have no meaning for the situation. So theme park attendance each year and the number of people. Well, you can't have a half a person. So therefore, you have very distinct points. Let's look at sketching graphs for situations. Sketch a graph for each situation. Tell whether the graph is continuous or discrete. Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. We can make a table to help us out. So, for example, if Simon sells 0 candles, he's only going to make $0. And then if he sells 1 candle, he'll make $2.50. If he sells 2 candles, he'll make $5. 3 candles, he'll make $7.50. 4 candles, $10. And you can keep going all the way up till he sells his 10 candles. With that, you would just plot each point. Can you sell part of a candle? No. So that makes the graph discrete. So your graph has your points each for each candle. And once again, you can't sell part of a candle, so it's not continuous. Let's try another situation. Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate raises at a steady rate. When she begins to run, her heart rate increases more rapidly, then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to normal rate. I find it much easier to, just like when we highlighted in that first example, maybe make a list so that you know which direction each part of your graph needs to go. So our list might look like this. So first it remains the same, then it raises at a steady rate, then it increases more rapidly, so steeper, remains high, slows down, and then returns to normal. So because you're talking about a heartbeat, it's not going to be stationary. You are going to have a continuous graph because your heart doesn't just stop beating randomly and then starts to slow down or go high. So let's graph. So in looking at the graph, it remains the same, then it raises at a steady rate, and then it increases more rapidly, remains high, slows down, and returns to normal. Alright, so let's look at this here. We have both graphs show a relationship about a child going down a slide. Graph A represents the child's distance from the ground related to time. Graph B represents the child's speed related to time. So if we look at this first one, you start at the top of the slide. This is probably very similar to the shape of the slide. So as time is continuing on, the child is getting closer and closer to the ground. Graph B is talking about the speed. So when you start on a slide, you start relatively fast and then you increase your speed and then you hit a point where you start drastically slowing down until you hit the end of the slide. So using this, we can write situations for graphs. So write a possible situation for the given graph. This is where you get to be creative. I will only be showing you one possibility. There are many possibilities when it comes to water level and time for this sort of situation. Now that you've had a chance to come up with your own situation, let's see what we have here. A watering can is filled with water. It sits for a while until the flowers are planted. The water in the can is then emptied on top of the planted flowers. Let's look at a challenge. Pictured are 3 vases and graphs representing the height of water as it is poured into each of the vases at a constant rate. Match each vase with the correct graph. See if you can do this. The answer will be revealed in a bit. Alright, so these are our answers. Let's look at and analyze each one. So as time goes on, the height of the water is going to increase at a steady rate because it's the same size all the way around. So it is increasing at a steady rate, and then when the glass starts to get wider, it takes longer for the water level to raise. So if we look at the second graph, it's taking you a really long time for the water level to rise. And then as the vase gets narrower at the top, it starts to take a much less amount of time to be able to fill up the vase. And now in B. In B, it's kind of increasing at a decent amount. So it's a little bit slower or a little bit faster, then it's a little slower, and then it's a little bit faster. So it follows the curve of the vase for B. And that ends our lesson on graphing relationships.